right. Are we ready to go? Ready to do this? Yeah. I think I'm ready. All right, so my talk is called Services and Rails, the shit they don't tell you. And what I'm going to be talking about is how Yammer builds services alongside Rails and talk about the things that we don't talk about often. So this is me. My name is Brian. I work on the Rails team at Yammer. And one of the things that we do is help extract out chunks of functionality from our giant Rails app into services and then integrate those things back into the Rails app. I also love Ruby, I love music, and I love Zelda. So what is Yammer? We build social networks for businesses that allow you to have conversations and collaborate across a lot of different business applications that you have. We use our own product pretty heavily at Yammer, and it allows us to basically never use email, which is awesome. And so this is an old image of what Yammer looked probably a year and a half ago. But it does a good job illustrating all the moving parts on this page. All the different colored boxes are different services that we collaborate with to build our front homepage here. And so if any of these aren't available, we still have some degraded state here. And oftentimes the user won't even tell that one of these services has gone down. And so real quickly, some fun facts about Yammer. We have over 100 web servers running our Rails app. We have over 40 Memcache servers. We do about 500 million requests a day to our Rails app. We have a 98% cache hit rate. We hardly ever go to the database. We do 240,000 Memcache gets a second and 20 billion Memcache gets a day. And so with that comes some not so fun facts. Our test suite takes about 10 hours to run. And so we parallelize it across 20 EC2 instances, and that still takes about 25 minutes. But we do have a second test suite now that is our fast test unit suite, which is helping a lot as well. So first, before we get into this deeply, I kind of have a pet peeve about titles of talks. And so I wanted to make sure that I didn't do the same thing that I have a pet peeve about. So I don't like when talks have a title that's kind of gimmicky, and then they don't talk about like what the gimmick is. And so I'm going to solve that problem here in a second. And so this is kind of the first conference talk I've given. This is the third time I've given it, but I had to prepare this presentation. So pretty new to this, and when I started putting it together, I had to think back to the last time I had to like speak in front of a class. And so I remember something then that was really important was kind of which template you were going to use. And so now we're part of Microsoft, so there are shitloads of templates. And so I found this slide in one of our templates, and I liked it a lot. It said, full bleed photos, pictures can set a mood or evoke emotion, making for a more memorable presentation. And so I really like this. And so I dragged this slide over to my presentation, and this is going to help with the title here. So every time you see this guy on screen, he's going to be helping tell us some shit that we don't talk about often. So this will be your little pointer. And so my intention with this when I was giving it is that it would help you guys know, like, when we were talking about the main points. And what it turned into when I talked to people after the talk and, like, a month later or something, they're like, oh, you're the guy that had that dude in all your slides. So that wasn't the intention, but at least I was memorable. So here's the first one. A lot of what I talk about right now might not apply to you yet. If you're building a startup to determine viability, you're going to ignore a lot of this and just get it done. All this is going to add a lot of complexity, and you probably don't know enough about your business and about your applications yet to do a lot of this. And so this doesn't mean that you don't have to write clean code and well-designed code. It's just hard to think about services at that point. And so if you have clean code, extracting that into services is going to make your life a lot easier. And once you know that you need to build services and scale, you're going to have to do some things that aren't comfortable. So here we go. Let's continue. So at Yammer, we have a huge fucking Rails app. 300 plus models, over 200 controllers. This thing is backed by over 20 JVM services now. And some of these services do over 1 billion requests a day. But at the end of the day, we still have this really large, huge Rails app. And this gets harder as we go, but largely we've been okay with this. We've been able to address it through kind of chipping away and building services. But things are still really painful when you get to things like sharding or upgrading Rails. These are all or nothing projects at this point, and that makes it really difficult. And so let's talk about service-oriented architectures. It seems like SOA has been kind of a bad word at this conference, but it enables us to do a lot of cool shit. So let's look at it and let's see what it gets us. This is kind of one of the main goals, is to achieve these components that scale individually. When you have these small focused services they're more versatile and they allow for much easier reusability. And so here's our Rails app. Here's a couple services that we have. And so with some prior search stack experience that we had, we were able to separate out these pieces of our search stack. In the middle here, we have a denormalized data store service that we take data from the Rails app, denormalize it, put it in this service for other services to talk to. And then we have our indexing service that builds Lucene indexes from transaction streams from this thing in the middle. And then on the edge, we kind of have our search interface. And so when we wanted to add another piece to the search service, it was easy. We added autocomplete here at the end, uses our same kind of data pipeline. And again, when we wanted to build a data export service, we didn't have to go to Rails again. We already had this stuff here. So this is great because we have all these different pieces now that we can scale independently, individually. So if we have these pieces broken up, like I said, it's easier to scale them individually. We can deploy these different pieces individually. We have a much better idea of each service's specific needs and its performance patterns, what it's going to look like in production. We don't have to throw resources at the whole stack where we may or may not need them. And this is all kind of enabled through this other benefit here. And it's this loose coupling. Compared to the monolith, which is much larger and broader in its concerns, this is smaller, more focused. We've encapsulated everything. Like I said, we can deploy and push out independent updates to things. And we can change out everything without telling anyone. Granted, our interfaces have to stay the same. That's a different problem that we can deal with. And so one of the things we're doing now, we're switching out our files backend. It's currently in Node.js, and we're switching it out to a Java service. And it's been pretty easy to do that because of these separated concerns. And so a second goal of having service-oriented architectures is maintaining these code bases that we can scale across our organization as well. If you've worked on a monolithic app, you've probably stepped on people. You've had to maintain a lot of logic and application knowledge in your head to know how these things work. And so let's talk about distributed execution, not in the computing sense, but in the development sense of it. Because we have loose coupling and we've divided our code bases up, it's easier for us to assign a team to the service and a team to the client or consumer, and they can coordinate and agree on how these things are going to talk to each other. One of the things we do pretty often is we build dummy components. So we can build the service but not implement the things yet, just expose its interface. And the client side can start sending data but not the right data. And so we can kind of start to unblock each other and keep working on things and then kind of fill in the pieces as we go along and see this end-to-end test come together. And so as I kind of alluded to a little while ago, this doesn't happen overnight. And again, when you're starting out your application or your startup, all of this is a lot of additional complexity. And it really prevents you from shipping product quickly early on. With a single undivided code base, you have the freedom to kind of change things really quickly. You can access data layers directly. You can share a lot of code quickly. And just avoid the overhead that managing services entails. So these are a lot of things you're going to learn iteratively along the way. And you're not just going to wake up one morning with services. And so we talk about Conway's Law a lot at Yammer. And kind of the key thing here is that if we have an organization that's optimized to avoid bottlenecks, we're going to create code that is also meant to avoid bottlenecks. And this is what it says. It says, organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. And so it's hard to think about services if we don't think about our development teams in the same way. A lot of organizations will divide departments maybe vertically or horizontally, which can lead to silos within the organization. People can be just working on the same thing day to day. That can get old, that can get boring. And it can also create barriers and cause people to get attached to their turf and just inhibit communication and decision making. So an example, this is something that we had early on at Yammer. This is the messaging team. We had a service that handled our message feeds and a team that supported all the messaging on Yammer. So they took both sides of this implementation. They owned the service, they owned the integration on the Rails side. And so this was their responsibility. And so like I said, they decided on the interface and implemented it. They had a really siloed knowledge of this system. And it's not always the most important thing that we can be working on. And then how do we scale this thing? Do we keep creating these feature teams? So we realized this wasn't going to work for us. And so we had to split things up a little differently. And so this is what we came up with. This is kind of where we're at now. And so we just started to divide things up like this functionally. We'd have a Rails team, and we'd have a core services team. Rails team would take care of the implementations of services on the Rails stack, and they would coordinate with this core services team on how things currently work and how we can make them good services and how we can accomplish this. And so the Rails team still has to know a lot of like this monolithic app architecture, and it's still a bottleneck for us. But the idea is that we can keep iteratively moving along, moving these things into services, and kind of reduce the amount of knowledge on the Rails side. But we did need to take this a step further as well. And so when we're creating a new service or a feature, we put together what we call cross-functional teams with representations for every aspect of the project. Usually our teams are about 2 to 10 people for 2 to 10 weeks. And people are constantly working on new and different things this way with new teams of people constantly. We have all kinds of projects. We have infrastructure projects. We have developer tools that we build. And we have core product features. So while we have all these functional teams, we basically have this pool of engineers that can work on a wide range of our problems. And so this is kind of what it looks like. This is an example of a cross-functional team. In this project, we would have maybe 2 Rails engineers, a core services engineer, someone on a mobile clients team, a product manager, and a QA engineer. So there are some other roles involved as well, but this is essentially the team. And these teams are autonomous and really close to the code. They negotiate the MVP with the product manager to make sure we're working on building the smallest chunk that we can so we can test our assumptions on our users. And at this point, managers aren't really involved at all. They're not writing code here. And we've got this team of individual contributors involved in this whole decentralized design process. And so what happens is these teams create these well-informed, isolated, and reusable systems. And so the key takeaway here is that these teams are ephemeral. They come together, they solve whatever problem they're solving, and then each team member moves on to something else. And since we don't have any management involved kind of at this level, we offload some of that to a tech lead for the team. So any one of these people could be a tech lead for the team. And it's really cool because this is a rotating thing that gives lots of engineers a chance at it. And so our cross-functional teams, they spin up, they learn the domain of whatever they're going to be working on. They take advantage of that distributed execution so they can work on things at the same time and not block each other. And then the team can coordinate on the API between the services and the client. And so again, the results of when this comes together are these naturally occurring services. And so this isn't to say that it doesn't have trade-offs. We do have some cost with not having siloed experts. Some would argue that this is a benefit, but there's definitely cost involved to having teams learn a new domain all the time. I think we're mostly okay with this. We also have to be careful not to couple the API implementation to the client. If we're building these things like as a feature team, we have to make sure that we're building the API properly and that as our mobile clients become smarter and need like this customized data, we're not thinking about just that. We haven't completely solved this yet, but we're looking at how other people have implemented solutions to this. And then after a project is completed, we still have to support the feature. So if we had a messaging team and a messaging bug came up, that would be easy to take care of. The messaging team would take care of it. In this world, there's no messaging team. There's our cross-functional team that did the feature, and then they're no longer there. So we also have another cross-functional team that we call our support engineering team. And they take care of all these like interruptible things so that our cross-functional teams don't have to be interrupted by things that they've worked on in the past. And it works pretty well. There is a lot of knowledge, it's a lot of things you have to learn when you're on support engineering, but it's this rotating thing, so you can have a chance at it and also come back to other teams. So here we go, here's the dude again. So there's more than one way to do this. When it comes to actually building the services, there are lots of ways and lots of things that can look like. There's no one way to build a service. And so many of our services kind of look like this. This is one of the easiest solutions. We put all the services behind Rails and don't let clients talk to them directly. They have their own backing stores, but they aren't exposed to the browser at all. They sit entirely behind the firewall, and the Rails app makes calls to them. And we'll talk about some of the reasons why it looks like this. But most of the reasons tie back to that these services grew out of the Rails app. And this gets us some partial win, but we still have to go through Rails and use Rails resources to get to these things. So we're not there yet. Eventually, you're going to want to get out of talking to Rails and go directly to a service. And sometimes this is easy. We have a service called Mugshot that handles dynamically resizing and caching our avatars and other images on the site. And it works well because it has very little state. It has this really focused concern. But this is kind of an incremental progression. Once we get to this point, we probably have to figure out authentication. How do we let the browser talk to these apps directly? We hadn't had to worry about that before, so you can kind of see moving through here. So like I said, there are lots of ways to do it. There's going to come a point where you have data that's in your Rails app that you want to get to from a service. It could look something like this. And reading directly from the Rails app's database it's not the worst thing in the world, but it's not great either. It's not a good idea. And then once you want to write data to that database, that can be a nightmare. Part of the problem with reading is that Postgres is in our database, memcache is our database. And so Rails knows about our caching layer, but our services don't. And as far as writing data, you probably have lots of code like we do in our Rails app that's going to make this challenging. And this is kind of why Active Record kind of holds your data hostage. And that's fine. It's made quite a few things easy for us as we built our app. But now we have to tear down some of the code that worked well in our monolith and get this data outside of Rails, maybe into a service. And so don't get me wrong, Active Record's awesome. It lets you do a lot of cool stuff. It gives you callbacks and hooks. It gives you validations. We can do state machines relatively easy with these Active Record models. We can hook it up to our caching validation, and that works pretty well. We have some hooks tied into Active Record with a gem called Record Cache that handles storing our records in memcache. So we hardly ever hit the database. And we rely pretty heavily on this gem for this. So all this stuff is awesome until you start to detangle some of this data and either access it from a service or try and move it over to a service. And so then it turns into this. Ugh, Active Record. I have all these callbacks and hooks everywhere. I have all these validations on the Rails side. I have these state machines. I have to worry about transitions. I have to worry about cache invalidation. And so we do have some options with this. I suppose you could say don't use Active Record. I know some people might not. We use it pretty heavily still. And then if you don't use Active Record, you still potentially have to solve those cache invalidation issues. A lot of what we do is we use our services as indexes and just store IDs of things. And then as the data comes back through the Rails app, we hydrate all those relationships. And then kind of the last option that we're toying with more and more, and we have some services that do this, is move the data completely out of Rails' realm and into the service so it owns it. And then we can, this is cool because we can hide away a lot of our sharding, our caching implementations behind this. We do have to remember, though, a lot of these things that we were hitting data for in the past, we're getting from memcache. So the service probably either has to have a caching layer on the client side or respond as quickly as memcache. And so once we get to this, once we've decided we want to move data, this basically means we're going to duplicate data. This is kind of what we're forced into. The chances are that you can't have downtime to move your data. And then what if the service doesn't work as we intended it to? Rolling back is really hard, but you need a backup plan. And so to duplicate this data, we do a lot of double dispatching. And so we'll backfill all the data to the service from the Rails app. And then new requests, as they come in, we'll write data to the database and post it to the service. And while all this is happening, we can monitor the service, kind of get a sense of what it's going to look like in production. And then we can slowly start to move to the service as we are more confident with it. And the backfill is really cool because it's kind of a peek into the scalability of this service. You're going to be putting data into it much faster than you would in production. So we can use this to plan capacity and just generally know how we expect this thing to perform. But once we've done this, now we have duplicate data. And so who cleans this up? We need to do it quickly because developers will become confused if there's data in the Rails app and in services. And we do fuck this up from time to time, and it sticks around and it's confusing. But this is part of a trade-off we have in our cross-functional teams. Our team disbands, and we need a way to make sure that this still gets wrapped up. Ultimately, we need to know when we're okay with going all in. And kind of the hard part with this is the old way is comfortable, and it's really hard because of this. We have to be okay with breaking our comfort zone and dealing with new issues instead of having this safety net of just jumping back. And don't get me wrong, you don't want to strand yourself. There should be an incremental period, but eventually you just have to make the call to completely switch over. There's some cost involved with maintaining this backup plan. And so far with all of this, we've added a lot of additional complexity. If you don't have a good story for your development environment, you're not going to be able to keep moving quickly. So we want to make shit easy for developers still. Part of the big win of services is not having to worry about configuring them or just how they work until you have to deal with one. All that logic that used to be in your Rails app that you kept in your head is now in these services. You know what the service does, but you don't care about how it works. And if this isn't easy, developers might wander back into their comfort zone, and that creates more problems. So basically what I'm saying here is use Vagrant. We have an awesome Vagrant development environment. These are some of the key points that we strive for. It's really close to production, running the same version of Ubuntu. We can run all of our services locally in our environment. It helps us keep up with these services that are rapidly changing and we need to keep developing the Rails app against. And again, we shouldn't need an intimate knowledge of the service or how to get it running. And so this is one of the tools that this is an internal tool that we've built that runs inside of our Vagrant VM instances that helps us manage this. So I can install or update any of our services from this panel. The key and critical ones come installed on the VM. And it pulls packages from our same infrastructure that we use for deployment here. So it's awesome because I don't have to worry about any of these services until I need to. I can run release versions, and it lets me update them so things work fine. But if I need to develop against the newest snapshot, I can do that too. But aside from that, I largely don't care. They should just work, let me keep getting my shit done. And so another part of making this easy is deployment. Again, we have quite a few apps and services, and we need any engineer to be able to roll these things out and quickly. So we need something that we can set up deployment for new services really quickly, and we need to deploy each of these things. And then we need to, again, maintain these stable releases and then these pre-release packages for development environments. And so this is our one-click deployment system that we've built in-house. It's extremely coupled to a lot of our conventions, but it allowed us to overcome some of the pains we had with Capistrano and getting new projects set up quickly for our other services as well. And so this allows any engineer to come in, click on deploy to an environment, pick an environment, and it starts running. And so another thing that's pretty important to us now is monitoring and alerting. We use a lot of different tools for this. For monitoring our JVM services and our infrastructure, we use Ganglia. Our Rails app uses some charting stuff that we've built in-house that I'll show you guys in a minute. We use New Relic a little bit as well. And a lot of this isn't necessarily specific to service-oriented architectures. There's so much you can learn about how your app performs in production. You guys have probably heard this spiel. But when you add services into the mix, you start caring about quite a bit more things. We care about things like making sure services respond quickly as we think they do. And in our Rails app, if we're talking to a service and it's not responding quickly enough, we hopefully just degrade and then move on with the request. But it's still important for us to know that this is happening, and so the alerts help us out here. So real quickly, this is the other tool that I just mentioned. We call it Charty, and it helps give us a look into our Rails app. We can quickly look at some of our most expensive actions and see how fast 99 or 95% of these requests return. Here we have, this is an API call to API v1 networks current, and 95% of requests finish in under 218 milliseconds. And so we can watch these trends over time and focus on what's important. And here's one more view. We can take this a little deeper too, and for that specific action, we can look at all kinds of different blocks of code that we've instrumented. And so here's a call to one of our services, feedy, which is our feed service. We can see that 99% of those requests happen in 54 milliseconds or faster. And so this gives us pretty good visibility as all this shit starts to come together and allows us to keep moving forward. And so having all these standardized deployment stories and dependency management systems will make your world infinitely easier when trying to manage tons of, rather than trying to manage tons of unique and special little snowflakes. And so with our services, we take this a step further as well. And we find it helps a lot when we have the same response formats and data protocols and monitoring interfaces. And so we use something called Drop Wizard that kind of grew out of some early services we had at Yammer. We basically packaged together all the libraries that we use when we're building a Java service. You can check it out at dropwizard.codahail.com. But basically, we get this simple production-ready service that's monitored, alerting, reporting metrics. But this doesn't mean that you have to use Java. We have some historical and some performance reasons for doing so. And we haven't necessarily discounted Ruby for anything yet. So again, like everything, we have trade-offs here as well. Service-oriented architectures have trade-offs. You have to know what you're getting into, the additional problems that you're going to have to solve. Some key points here are that now we have to handle unavailability. As services go away, we have to know what that looks like. These transactions aren't completely free, so instead of just going to the database and getting everything, we have to go to these different services to get it. We've done some things that we're trying now with like parallelizing some of these calls, so we can make that faster. The APIs are much harder to change as you have these services. If they're just in your Rails app, you can kind of make much quicker changes. Now we have to coordinate changes or go with versioning, something like that. And again, there aren't atomic deploys of these things. If you deploy a change to a service, you're going to have clients that are on both sides of your deploy. You can't really do a coordinated deploy where you like deploy these things at the same time. It doesn't work well. And so basically what this boils down to is that complex systems fail. Again, you have to think about degrading for these unavailable services. And it gets really hard because you have to chase issues through multiple levels of indirection. People don't know where the problem is happening necessarily. The place that's throwing the alert might not be the one that's causing the issue. If you have like a queue backing up, it could be because like a service got slow or something like that. Basically, you want to know what happens when shit blows up. It's really important here to know this, that when a service goes down, what happens to your application? We had an issue recently where a service went down, another service depended on this service, and it didn't degrade properly, and it didn't time out the connection when it couldn't reach the service. So this created this chain of effects for us. This is a service that we hit directly from the browser, and basically the service never timed out or closed the request, so it just hung until the browser timed it out. In Safari, this is like 5 minutes. So other things in our web client couldn't process while this other thing was just trying to time out. So bad things started happening. And we thought we knew what this looked like. The kicker here is that this was our prospective rank service that went down. So things might have been out of order, like is what we expected to happen. But what actually happened is our web client was completely unusable. So know what's going to happen when services disappear. Try it out in staging. Try it out in your other environments and see if this service goes away, what's going to happen. All right, so let's recap some of this. We talked about a lot of stuff, and there are some key points that I want to leave you guys with. So always reevaluate your costs and their viability. And I'm not talking about like the financials. I'm talking about the trade-offs that you've made, and if those are still the right choices. Are you okay with these trade-offs? Is something slowing you down? Know what an inflection point looks like and what it means to your software. Don't scale before you need to, but be ready to do so when the time comes up. And once you've determined that you need to scale with services and that you can take on this extra complexity, you're going to need an organization that supports building these services. And this could mean more than just changing your development structure. This means giving priority to building the tools that you're going to need, and creating a culture around building services. Some things are going to get a lot harder. Deployment's going to be more complicated, but all these things are okay because we've reduced the amount of required effort in some places, and as the system gets larger, it's much easier to maintain. So again, we're going to need these tools that allow us to keep moving fast. Building services can't slow you down. You still have customers, and you still have to deliver value to them at the end of the day. And they don't and shouldn't care about any of this, but they're going to care if things start going wrong. And again, if developers can't build services easy and if they're up against a deadline, they may just start adding more to the monolith again. It's easier for them, and then they can just worry about it later. And so this is the last point that I want to leave you guys with. And this is something we talk about a lot at Yammer. Be ready to be wrong. You're going to make a lot of mistakes doing this. Be ready to acknowledge and recover from those mistakes. I think we've rewritten our search stack like 3 times, but we learned a lot about building services and what we needed to do. This is the same in code too. We look back at code that we wrote, and oftentimes it makes us want to go back and punch ourselves in the face. Decisions about building services and how you organize can be the same way. And so don't assume the decisions you made yesterday are still the right decisions today. It could very well have been that the decision that you made yesterday was right at that time, but today the situation's changed, something's different. And this is really hard to do. Like I said, we still have a huge Rails app, and we haven't solved that problem yet, but we use all of this to try and make it better. So again, I work at Yammer. You can check out our engineering blog, and my name is Brian.